Hello everyone, in this video let us see this quiz question. The ramp function can be obtained from the unit impulse at t is equal to 0 by, there are 4 options given: integrating unit impulse function twice, integrating unit impulse function once, differentiating unit impulse function twice, differentiating unit impulse function once. And 51% of the students, they have given the right answer. And let us see the solution for this. So, you know, delta of t is nothing but it is a unit impulse input, delta of t. Here we will see that it will be defined for t is equal to 0. It has infinite height and it has area 1. Okay. So, you know that minus infinity to infinity delta t dt that is equal to 1 and delta of t that is equal to infinity at t is equal to 0 and 0 otherwise. Okay, so you know the definitions for the unit impulse input. So now you also know the unit step input. Unit step input means u of t. How will you draw that? From t is equal to 0 here, you have this continuously, right? And the magnitude here is 1. So this is your u of t, that is a unit step input, and r of t is unit ramp where you have this, okay, which will be continuously increasing. This is r of t and t. So you also know r of t can be written as t u of t, right, where u of t is unit step. So now how can we get this ramp? How can we get this ramp from the unit impulse? So you know, when I differentiate this, I will come in the reverse way now. So now I have ramp function. What happens if I differentiate ramp? This is nothing but d by dt, okay, of t of u of t. That means if I have this, if I differentiate this, what I am going to get? I am going to get the unit step, right? So I am going to get unit step. Next, if I differentiate the unit step, I will be going to get the impulse. So differentiating this, and after differentiating this, you are going to get the unit impulse. So that means d by dt of r of t that gives you u of t, and d by dt of u of t that gives you delta of t. So if I do the reverse way, that is reverse of differentiation will be integration. So if I integrate delta of t, I will get u of t, and if I integrate u of t, I will be getting r of t. That means if I if I integrate this twice, for one time integration that will give you u of t, and another time integration that will give you r of t. So this is integrating twice. So integrating unit impulse function twice, that will give you the ramp function. Okay, so option A is right. Integrating unit impulse function once, only once, that will give you unit step. Okay, then differentiating unit impulse function, okay, that is d by dt of delta of t. I think you have heard about the doublet. Okay, so that, so only the option A satisfies here. So A is the right answer.